Hi all, thank you for joining. My name is Ranjan Priyadarshi, and I will be the moderator and host for this session. We have a very exciting and well-crafted agenda planned for today, and I'll share that shortly. Today, as well as tomorrow, we're gonna talk about one of the crown jewels of Oracle database, so stay tuned. So we are excited hosting this summit for you, and we are excited that you are here. And glad you could make it. It would have been much better if you had done in person, but thank you for finding some time in your work hours or off work hours for joining this summit. Summit is all about you, and the summit is all about collaboration. We welcome you all. Whether you're a customer, partner, industry consultant, Oracle sales, marketing, product development, we welcome you all. And there is something for everyone here. And let's together build some exciting solutions for future enterprises. Please also join our community. And I will share the links of these communities that we have built on LinkedIn or Twitter. And please provide feedback, propose new enhancement, and ask questions or build something together. This is what the community is meant for. Also, we are recruiting customers for our customer advisory board. So let us know if you are interested to join our customer advisory board. Kind of switch gears and talk about why we are here. And talk about some telecommunication things. So, you know, telecommunication has advanced from 1G to 5G. And when the 1G came out, there were big phones and bad voice qualities and all poor experience. 2G added few capabilities and so forth, right? And the 5G has kind of definitely a speed of 1 gigabyte per second or more, right? So there is a drastic change between 1G and 5G. And it is kind of estimated that with 5G, 50% of the e-commerce business will be done through the mobiles, right? So basically what has changed between 1G and 5G is just the speed of the data rates. And so the speed can definitely play a massive role. So what we are seeing is that many of our customers are actually stuck in 1G, 2G, and 3G analytic solutions. And our goal and ambition is to move them from 1G, 2G, and 3G to really a 5G and 6G solutions that we may be working on at now. Okay, so really speed can change the way you can think about your business. And this is the right time to think about how you can change the way you think about your business and introduce new differentiation, better services, new business models into your business. And it's time to adopt the 5G speed for your analytics. And this solution is not new. Many of the customers have already adopted this 5G solution. And the largest electronic manufacturers, one of the largest automaker, the largest retailer, the largest communication product provider, and so on. The list goes on. The biggest, the best are already taking advantage of database in memory to maintain lead in the market and to provide the better customer experience and service experience. And as you're working on digitalization and modernization, the fast and real-time analytics will be the necessity and the key enabler for your solutions. And basically everyone will need the faster and real-time analytics. And what are the performance benefits or the business impact that have the customer seen? Okay, and this is where the chart is. All this data is public. Let us know if you want to kind of look at any of these reports. Many of these customers have seen up to 100x performance benefit, whereas a lot of them have seen 4x, 3x as well. So the mileage does vary, but of course, many of these customers have seen drastic performance benefits here. And we would like to see your names and success stories at the next summit on this page. So in summary, Oracle database in memory is a game changer. And this is a quote from our customer. And as you hear various presentations, think about what application and use cases you can apply database in memory. how can you get started and how can you get most value? And we are all here in the journey to help you in adopting database in memory. Now switch gears. So today and tomorrow, we're gonna have various experts. They're gonna be talking during the summit. And today we will have 2 keynote speech, and then we will have 2 technology deep dive sessions. Okay. And tomorrow, please call in for listening to all the customer success stories. And this is the agenda. I believe most of you should have the agenda. But again, we are here in session 2, and tomorrow is session 3 and session 4. Both are unique in the terms that session 3 has 2 customer presentations and session 4 has a different customer presentation. So feel free to call in to both session 3 and session 4 tomorrow as well. Some housekeeping items before we start. Please do ask questions. We love questions. There are several panelists and experts available to answer your questions. And also, I will paste this link of the LinkedIn channel. Please subscribe to this group. And the sessions are being recorded. And also use use the hashtag DB_InMemory to talk on the social media. With that, let me stop sharing and let's invite the first speaker for the keynote, Tirthankar. So Tirthankar is going to talk about Oracle Database in Memory, warp speed for the enterprise. Tirthankar Lahiri is a Senior Vice President of Data and In-Memory Technology Group for Oracle Database, responsible for database engine, including tables, indexes, in-memory transactions, the Oracle timestamp, and Oracle NoSQL database. Tirthankar has 25 years of experience in the database industry. He has 45 issued patents and some pending as well. As I mentioned, he's going to talk about Oracle Database in Memory, warp speed for the enterprise. So in-memory computing is more than simply about speed. It enables a fundamental transformation in business processes. Just as air travel enabled more than just the ability to travel faster, it enabled a completely new global economy, reshaped the politics, and transformed society. Oracle Database in Memory options similarly enables not just faster analytics, but a fundamental rethinking and drastic simplification of the traditional analytic platform. Over to you, Tirthankar.
Hey, thanks, Ranjan. Let me start sharing my slides. Hopefully you can all see this, right? You all see the Starship Enterprise and how we achieve warp speed for your enterprise with database in memory. So thanks for the introduction. Let me quickly start showing the rest of the content. I'd like to start actually by talking about a different kind of enterprise. I'm hoping many of you are Star Trek fans like myself, but the enterprise that we're concerned about really is your enterprise, your business. And what all enterprises aspire to be today is to be an enterprise that can react in real time, a real-time enterprise. It begins with the enterprise basing decisions on actual data, not based on instinct, not based on hypothesis, not based on any other faith, but actually based on data. And with that data comes the ability to actually make decisions quickly. So if a store is going to run out of milk before the end of the day, the store can then quickly reorder milk before it actually runs out. So things that make the business productive and profitable in response to real data and real observed data and trends. And so agility is a big thing based on data, take agile decisions. And of course, the long-term goal is to be efficient, that you have to take short-term decisions, but you have to look at your trends, look at your forecasts, and over time optimize everything in the business to maximize revenue and profit. You might see trends as certain products are doing better than other products depending on what's going on in the world. And with those trends in mind, you can optimize your supply chains in a way to maximize profitability. And maybe invest less in the products that aren't growing as much, for instance. Now, there's many examples of real-time enterprises. I'm not going to bore you with going through every single one of these, but suffice it to say, in insurance companies, in retail, in manufacturing, in financial technologies, fintech, in telecom, all of these businesses have a need to respond to events in real time. And a very good example actually is financial services. If I have a transaction that is fraudulent, I don't want it to go through if the fraud scoring algorithms disqualify it. Let me turn my video on briefly. Sorry, I forgot. So the idea is to catch it in real time and exclude it based on real time fraud metrics. This is important in today's world, especially. You can't wait for things to happen and then react after the fact. So every business vertical there's a need for real time responsiveness. Now, I have a few polls that I'd like to just send out, right? So I'm going to start with the first poll. Is whatever company you happen to work for, do you consider your company to be a real-time enterprise? I'm going to launch this poll. There's some other questions on the poll. Feel free to answer them now or do them as they come up in the presentation. Ideally, we would have created 3 separate polls, but right now this webinar has only one poll with 3 questions. But feel free to go ahead and start clicking on responses. I'd like to make sure all of you respond before I end the poll. So please go ahead, take your time, but do start answering the questions on the poll. I hope everyone can see the poll. Is the poll visible? There we are. I see people answering already. So thank you for that. That'll be helpful for us to know how much knowledge of InMemory there is and how relevant this technology is for your use cases. All right, so the real enemy of the real-time enterprise is actually complexity. Believe it or not, you can be too sophisticated, and sophistication comes at a price. This is a very common sight for those of you from India. I'm from India myself. If you've walked around India on the streets, you'll find junction boxes and connections on the street lights that look something like this. It's very, very commonplace in India. I'm sure all of the India attendees here can relate to this picture. This is sort of what happens when you allow complexity to grow unchecked. And in the enterprise world, it's the proliferation of technologies, different systems, different implementations, and they hurt everything. They hurt security, hurt administration, hurt diagnosability. They make it very difficult to be agile and efficient. Forget being data-driven. Just making sense of this is very tricky. Now, this, of course, is like a physical street light with a lot of wires tangled up. But what about the enterprise world? This is the equivalent. This is actually the enterprise architecture of a very successful web company, I might add, because it's a giant web company with a huge, huge presence globally. But they're, sort of $1 trillion company, and they can afford to hire the top MIT PhDs each year to keep this infrastructure running. It's not for everyone. Just like Formula One racing isn't for everyone, this is sort of the extreme cutting edge of complexity for an enterprise. If you look at this picture, they have no less than 9 different data stores. So there's a few database OLTPs, some for analytics. This creates major problems. You have multiple technologies, multiple copies of data. We call it the copy contagion virus, where the same data can exist in different logical forms in different repositories. Makes it very difficult to run reports consistently. I have no idea how anyone takes a backup of this system. You can't take consistent backups if every database is running independently. When you have multiple components, like when you have a very large house, your weakest room defines your security. The same thing happens for enterprise architectures. Your weakest product defines your security level. And this thing is a real, honest to goodness, living nightmare to maintain. And it's only possible with, like I said, a massive army of some of the top, PhD students and the top graduating class from MIT. It's possible, but it's not for everyone. So this is the equivalent of the Indian street junction box that is a very familiar sight in India. This is the enterprise equivalent. I call it DIY by DIY, which is an American abbreviation for do it yourself. I'm personally horrible at DIY. I'll prefer to hire people who can do the work for me for most handy work. And this is a good way to die, by trying to do everything on your own and building these one-off integrations of different technologies. We don't want to get there. But let's see how easy it is to get there and how easy complexity creeps up even with a simple application. So I'm going to walk you through the thinking behind the design of a very simple app that most of you can relate to, especially in this pandemic-stricken world where all of us are basically getting most of our products and goods and services online. I believe that's true for most countries. Definitely true in the US, where if I didn't have Instacart, if I didn't have Uber Eats, I really wouldn't have groceries or restaurant food at home. So let's imagine building another app, another such service called Megacart, which contains the following actors. There's actors that are customers who place orders transactionally. The stores, of course, process orders. They connect the order with the delivery service that delivers orders. And there's a business analyst or an analyst team that looks at business metrics to see what can we optimize and do better in. So the app logic contains transactions to fulfill orders and deliver orders, as well as analytics for instant decisions. So for instance, if a store is about to run out of something, just like I said, get me, restock that inventory. If a customer wants to buy something for a certain type of product, recommend stores to buy it from. And also the analyst will want to see, well, which stores are seeing a lot of traffic, which products are popular. Maybe we need to stock up more on those inventories. So there's a behind the scenes optimization that needs to happen to keep these stores well stocked with the right set of products. So it's a very simple premise for the app, not complicated. And the first step is you define, I'm a database guy, so for me it's second nature to think, okay, there's a simple normalized database schema I create of customers and tables that contain customers and items and deliveries, etc. They have relationships between them, they have indexes, and within a fairly short time you can write an app that'll get this running. You'll have a single database, the simple schema, very simple architecture, fast transactions, and you can get up and running very quickly. Not a big deal to do this. This so far is simple. This is good. But unfortunately, it's not enough. The next thing you'll need is you will need to create indexes for real-time analytics. Like I said, if I am about to run out of a product, I need to know what products I'm running low on so I can order restocking as a store. If I'm a customer buying something, I want immediate recommendations about where to buy it from, what else I might want to buy along with it. A lot of my shopping online is driven by these recommendations. I'm buying X, so maybe I need Y. And I think about it and I say, yeah, they were right. If I'm buying X, I probably do need Y. So let me add Y to my shopping cart. Now it's too late to do that after my shopping cart has been filled and the order is in progress. So they have to get to me before the cart is actually checked out. So for that reason, I need to add analytic indexes that can basically do these types of queries and run them in real time, find which orders are pending delivery, which items are running low in inventory, things like that. So I have to add these blue indexes. But it is a little complicated because now I have to first know what the workload is going to be, anticipate my queries, and create indexes based on workload knowledge. The indexes also add overheads. They do slow down transactions. If a table has 10 indexes, they have to all be maintained when you insert a new row into the table. And they increase database size. And we have seen databases where 70 to 80% of the database actually is consumed by analytic indexes that are present because of some infrequently run reports. So it's still simple, but it's not as simple as before. But again, it gets worse because the business analyst needs to look at longer term data. And what they do is run queries that look at trends, look at quarterly growth, look at product sort of performance across different time zones or different, let's say, zip codes, for instance. These are longer term queries. And the classic way people do that is they create a reporting database. That's a transformation of the source database. Not the same copy of the data, but a reporting database that has a transformed copy that takes my normalized schema on the left and creates a conventional star schema on the right, where every sale is a separate fact, and each fact has its dimension tables with like customers and products and stores. And then this database also has its own indexes. Now this database alone more than doubles complexity because it's another database I have to manage. I have to extract data from the operational data store, transform it and load it, and declare this totally separate transform schema on that database. So now my application is now running on not one but two databases. And so yeah, things have become more complicated. It doesn't end there either because I will have a lot of queries the analyst needs to run that run frequently. Now, we don't want those queries to trigger massive computations by performing complex star joins each time. So the most reporting database will actually have pre-computed summaries and aggregates, materialized views, etc., cubes and rollups that are maintained as the star schema tables are modified. the pre-computed summaries are updated. They're sort of like another level of analytic indexing, but ones that deliver specific targeted reports like quarterly sales or monthly deliveries or my top selling products. So this is now a lot more complicated because now I've got multiple sets of schema objects that are basically workload dependent, add a bunch of overhead, and have to be built based on workload knowledge. So now it's become, it's no longer this simple application that we had at the very beginning. What is complicated about this? We began with a simple operational database, right? Jumped ahead here. We added some indexes, but then we had to add a bunch more analytic indexes. And then we had to add another database with more tables and more indexes and more summaries. All of these things contribute to complexity creep. You can see that the relentless march of complexity is upon us. And I haven't, I could continue, but people typically add additional data stores like maybe data lakes or other object store repositories, more things to surround this architecture with to facilitate analytics that are longer term. So anyway, as you can see, we're well on the way to getting to be this enterprise sprawl architecture, beginning with a very simple design. We have a much more complex design now. What we want, though, is something simple. We want simplicity. We don't want complexity. We really want everything that this workload needs to run on one database. Now, we are happy to scale out the database. There's a lot of scalability technologies in databases. We don't mind scaling out the database. We don't mind a large cluster database. What we mind is having separate, disjoint, independently maintained databases. What we want is not to require a reporting database, unless in certain cases, of course, you need one. If you're trying to aggregate from multiple sources, you might need a reporting database, but not for this use case. This use case is really simple. I don't want to have to create predefined indexes or pre-computed summaries analytics. I want analytics to run fast no matter what. And most importantly, I want all that workload to run on that operational database. So the question is this possible to do, right? And the answer, which I wouldn't have asked this question if it weren't possible, the answer to that question is yes, it is possible. I hope that doesn't surprise anyone that it's possible. And it's made possible by this great technology that Ranjan mentioned. It's called database in memory, the reason that all of you are here today. Database in memory really provides the ability to run real-time analytics in the middle of a high throughput OLTP application. And it's based on a very simple, basic concept that there are two ways to represent data in databases. Historically, databases are based on the row format. So, you have data organized in rows, which are really good for, insert, update, delete transactional applications because all the data is stored together. And it's great for transactions, but it's not optimal for analytics. On the other hand, the column format, which again is not a new concept, it's been around actually since the early 90s as a concept, where you organize the data as columns, not rows, where I can just access the data I need in my column and avoid looking at extraneous data and get my results quickly. So rows are good for OLTP, columns are good for analytics. Database in memory provides both at the same time for the same given data. So the idea is OLTP operations automatically use the highly concurrent existing row format in the buffer cache, and analytics uses the new in-memory column format using a magical trick called CMD Vector Processing. I'll talk about that in a bit, achieving billions of rows per second scan speed. So you get your massive transactional throughput along with your high analytic throughput on the same data at the same given time, at the same time. And these are both consistent copies. So no matter where the operation is sent by the optimizer, it gets the same results no matter what. So before I go further, I'd like you just to draw your attention to question number 2 in the polls. Again, you might have already answered the question, but I'd like to know how much you know about database in memory. It'll also help the other presenters today to know how much detail they should go into. So please feel free to answer this question, or if you've done it, thank you for that. And feel free to admit that you don't know nothing about it. It's perfectly reasonable to know nothing about it and to come here to be educated about the technology. That's reasonable. But if you are, an advanced user or a current user of the technology, it'll be good to know that too. So please let us know what your level of understanding is of in-memory. The in-memory column format is the new underlying format for the database in-memory feature. This is what's new in the technology. It's basically built in memory from the row format underneath. Because it's in memory only, modifying it, maintaining it is fast. It doesn't require logging or disk persistence, has no impact on compatibility and upgrades because it's volatile in-memory structure. It's available on every platform, and most importantly, because it was built natively into the Oracle database, there are no ridiculous exclusions like in many other products. Like everything works with memory. There are some products where if you put something into memory, then certain features stop working. We don't have those limitations. All the enterprise features that you need in the database, like security, availability, scalability, they all work transparently. Things like data guard work transparently. Another important thing that differentiates this from conventional in-memory databases, pure in-memory databases, is that the whole database does not need to be in memory. You can selectively put whatever subset you want into the in-memory column store just for your hot data. Most applications observe the Donald Knuth pattern of spending 90% of its time in 10% of the data. So you don't really need in memory to store your 100% of your data if you're only going to be accessing 10% of it. So you can selectively put the hot partitions, the hot table spaces, the hottest tables into the column store and leave everything in the row store and let the buffer cache handle access to the older or colder data sets. Very simple, very flexible. The real magic behind in-memory columnar processing is this technique called CMD Vector Processing. Now, this by itself is not a new concept. CMD has been around actually since the 70s in vector machines. What has happened of late is because of the explosion in gaming and in sort of data science and other techniques and computer graphics, that even the mainstream chips decided that we need to add this because our applications need it. And SIMD is very simply single instruction, multiple data. The way it works is you can process multiple values, like add multiple values or compare multiple values in one instruction. So instead of having to do a loop across these values and do them one by one, I can do a batch of them and compare them in one clock cycle against the value I need to compare with. So finding all the sales in California, I can do a whole bunch of them in one shot using SIMD vector instructions. And this is really the heart of the technology, the reason that we get this massive acceleration in performance, because we can really now process data in these units, not one by one, in these blocks of units at the rate of billions of rows per second. And no matter how good your row format design is, rows can never return data at the rate of more than a few million per second. This SIMD combination column storage really gives it this massive boost in performance. Now, in-memory basically makes everything in analytic reporting faster. It makes scans faster for the reason I mentioned, that you access only the data you need, you scan and filter using SIMD instructions, and you basically can exploit the full power of the memory bandwidth of your system. Because scans are so fast, they effectively replace analytic indexes, and I can do joins really quickly just because the scans are so fast. Now, so for instance, if I'm looking at a join between sales and products, trying to find all the sales of swimwear, I can first do a very quick scan of the products table, find all the swimwear products in my products inventory, and then scan the sales table to find out, hey, which of these sales correspond to swimwear sales. What I've done is replaced a join effectively with a couple of very fast filtered scans, leading to a massive performance boost in running the join. And the same idea extends to more complex reports, where if I'm trying to find, say, sales of swimwear in stores in California, total sales of swimwear products in the state of California, I'd first create an outline with all the combinations of product and store and have a cell for each entry and increment outline as I run the scan on the fact table. I'm giving a very high level idea, so I'm not giving you the full details of the algorithm, but the basic concept again is because the scan is so fast, I don't need indexed access any longer. I can build everything I want from the report just by doing a series of fast filtered scans. And this gets you again a 10x boost or more in scan performance. It also accelerates mixed workloads and transactions in mixed workloads, most importantly, like Megacart. And the reason is very simple. As I mentioned earlier, Megacart needs my OLTP indexes, obviously. I have to have index for primary key relation and foreign key relationships. I can't avoid having those indexes. So to find all the orders for a customer, I need an index lookup for that. Those indexes are essential. But I also have to have indexes for analysis, like the inventory of product. So I have to have a index on the inventory column for product, for instance. The drawback of having these indexes is as the number of reports grows, the number of indexes grows. And every time I do an insert or a DML on the base tables, I have to maintain these indexes, which slows my workload down. And the more problematic thing is I only get speedups if I have the index. If I'm missing an index and I fall back to doing a full table scan, I'm going to run really slowly. And of course, the analytic indexes also make the database bigger. In many cases, the database is mostly full of indexes. There's less data than index in many cases. Now, with the in-memory column store, you can replace these indexes with the column store. So now I just keep my OLTP indexes. My in-memory column store becomes like having an analytic index on every single column. The column store isn't persisted, so updates to it are fast. And I don't have to anticipate the workload because once I create the column store, any analytic query will run fast. And not having analytic indexes makes my database size smaller as well. So it's a very good replacement for these analytic indexes needed for real-time reporting. But in memory, but you might ask, well, I might have data that doesn't fit in memory. What do I do then? If my data is large and I'm looking at historical data particularly, like in Megacarts, the business analyst looks at historical data. How can in-memory help there? Well, the solution is very simple. We have this great database platform called Exadata. It's the ideal database machine, and Andy will talk about that in his presentation later on. We have made the in-memory format available on Exadata storage in the columnar flash cache. And what this does is very, very impactful. It extends in-memory not just to run on the DRAM of the compute service with the actual database function running. It expands it to the storage service, and which means that all my offloaded operations to storage can have the same benefits as the benefits from in-memory on the compute side. So if I'm running a query that offloads the scan to storage, looking for, say, sales in the state of California, and I'm looking for sales across the last 10 years of data, I can simply run that scan on the storage tier on the in-memory organized flash and retrieve those sales at the storage tier without having to communicate with the database compute node and return the database compute node only the final result. The big benefit is that there's a lot more flash than memory in practice. On the new generation Exadata, I think we have up to 0.5 petabyte of flash on a full rack X8. So instead of having to create a separate reporting database, you can simply expand your column store footprint down to the storage tier and avoid the need to create a second database. So it's all one database still. The query offload now runs in the storage tier, runs with the same in-memory performance benefits on these in-memory formatted flash storage units. So very, very powerful technology, expands the reach of in-memory to much, much larger data sets. A database in memory is, it's a very, very active technology area for Oracle Database. It's one of our flagship technologies, as Ranjan mentioned. We've done a lot of work to enhance it since initial release in 12.1. It's been a while, actually. Time flies. I think we released 12.1, 12.102 actually was released in July 2014. In fact, one anecdote I'd like to share with you is that this is the only major feature I know of that was released in a patch set in 12.102, not in 12.101. It was done in 12.102. And it was possible because it had so little impact on the stored format. Normally, we would never release like a feature like this in a patch set. But because it was ready, we said, why wait for 12.2? This doesn't affect anything on disk. There's just adds a bit of DDL to declare things in memory. We were able to get it done in 12.102, and it was like a fantastic success, right, on day one. I think it's the only thing I know of in my time at Oracle, something of this size, that was released in a patch set. And we've done a bunch of work since then. We've, of course, been significantly, and now Rich and the others will talk more about the more recent enhancements, but the big push in Oracle database is to move to a more converged database model where we run multiple workload types in the same database engine. So with that in mind, we've been expanding in-memory scope to include things like analytics, text processing, etc., to allow it to handle more use cases. So, and of course, we try to make this technology more self-managing so that it requires less human intervention. In the modern world of autonomous computing, we don't want a lot of self-management needed. So that's been another big focus for us recently. This is not a poll question. This is maybe a trick question. If I'd like you to think for a second: is who has the best in-memory technology? Now, again, I wouldn't be asking the question if the answer weren't Oracle, right? That's a given. Now, you might say that, hey, Tirthankar, you're biased because you happen to work at Oracle, so of course you'll say that. Now, you're right about that. So I wouldn't be the right person to ask that question. But this is actually based on analyst surveys, not me. Every report we've had that has actually evaluated in-memory technologies has put Oracle at number one. So Forrester did the first in-memory wave in 2017, and they put us ahead of other sort of dominant players like SAP at that time had HANA, but they put Oracle ahead because they liked Oracle's approach better than SAP's approach at that point. So Oracle was the leader in 2017. In 2019, Forrester said, look, in-memory is table stakes. It's a key core technology. The real thing that matters is translytical workloads. Actually, I like the name translytical workloads. It means it's an analytic plus transactional workloads. And obviously, for translytical workloads, you need in-memory processing to get the performance of real-time analytics. So they liked Oracle's dual format approach again and again ranked us number one in the 2019 wave. Gartner, another very popular, very powerful database analyst firm, rated Oracle number one again in their definition of translytical workloads. They call it augmented transactions, like augmented reality. A transaction, they're not simply doing insert, update, deletes. They're doing things like machine learning. They're doing actually real-time analytic processing. And again, these things require in-memory processing. So they ranked Oracle database number one in 2019. Last year was the first year they did a pure cloud operational database study. And even on the cloud, they looked at Oracle's autonomous database offering, autonomous transaction processing, and again placed us at number one for augmented transaction processing. So again, don't take my word for it that Oracle's number one. It's what the analysts have said. So I'm just repeating what they said. As Ranjan also mentioned earlier, in-memory is truly transformative. It is a very, very fundamental shift in the way people do things. It's like the difference between walking and running to the city of New York. I mean, I could walk to New York. It would take me a very long time. And flying, sorry. I shouldn't have said running, excuse me. Walking and running, with my running abilities, wouldn't make much difference. But if I could fly to New York, it's much, much faster. And in the old days, people had to take ships to cross the Atlantic. If you had to go to London to do business with your London client as a New York firm, you would have to send people on a ship. In fact, I believe in the early days at some point in the 19th century, when sort of ocean travel really picked up, people would even write their wills before leaving, before they left on these voyages, because who knows what might happen on the ship on the journey. The ships became much safer, became much faster, and journeys were completed. I think the fastest crossings were in 5 or 6 days, but still, it's 5 or 6 days of travel to get to your destination. Air travel changed all of that. You could travel within a day and get to your destination and do business the same day or the next day. And it changed everything. It changed business, it changed politics, trade, education, sports, defense, everything. Everything changed with air travel. It was not just traveling fast, it changed. It was a societal revolution, a completely new paradigm, a new way to do things. In-memory, just likewise, does not just improve performance. It's not simply a performance win. It's really about simplifying your architecture by giving you this massive speed. You get instant results, so you can make decisions more quickly. You don't need to have multiple systems for reporting, so you can lower costs. And in the process, build a much simpler, much more agile enterprise architecture. So it's again transformative in the same way that air travel transformed society in the 20th century. And for the Megacart application scenario, InMemory brings you similar benefits. You can actually now run everything on that same operational database. You have your OLTP schema, you have your essential OLTP indexes. You cannot not have OLTP indexes. You have to have those. But the in-memory column store replaces the need for the analytic indexes. The in-flash column store replaces the need for having pre-computed, the reporting database. Instead of a second database, I can just expand my column store to flash and run the long-term queries there. And my in-memory reporting thing that I mentioned earlier, where I can run reports in real time using very fast scans, replace the need for pre-computed summaries, because now I can just rerun the query and the queries run really fast using CMD vector scans. So all this gives me is I get fast transactions and analytics on the same data, on all the data, without having to know my workload in advance, all on a single centralized database. So this is simple. This is what you really want for an efficient architecture. There's a lot of different use cases of in-memory. I believe Lufthansa will be speaking tomorrow about their use case. It's one of my personal favorites because I do enjoy traveling. I look forward to traveling again as soon as the pandemic allows. Lufthansa has a process where they refurbish aircraft. In fact, they do it for multiple airlines. They're really good at it. So a lot of airlines will subcontract Lufthansa to maintain their aircraft. So I think every 6 years they basically take apart an aircraft from bow to stern and then decide what the state of each part is and which needs refurbishment. And if you can imagine, a modern Boeing 777 has several million parts and subparts. And they were bottlenecked initially on the performance of analytic queries to figure out which parts had to be refurbished first. So with in-memory, they were able to speed up that reporting process significantly. By not having analytic indexes, they made data ingest much faster, and they reduced the database size by dropping analytic index. So everything I mentioned earlier came together in Lufthansa's case. But if you look at all these examples of customers, there is a common theme here. Faster reporting, faster OLTP by not having indexes, as well as reduction in database size. If you look at Mankind Pharma, that's an India-based ISV in the medical space. They got a 90% reduction in database size by dropping analytic indexes. So this is significant. This is not a trivial reduction in database size. So a lot of these applications of in-memory involve reduced cost, reduced storage costs, faster ETL processing, faster transaction processing, as well as faster analytics. In fact, Bosch is a good example of a customer that didn't actually want faster reporting. Their issue was they had performance issues running batch workloads because of index maintenance. So they were able to drop their custom indexes completely. And they had, faster analytic queries, and the batch and DMLs became much faster as well. So it's a good testament to the power of in-memory, where you can drop indexes on the confidence of having the column store to pick up where the indexes would have actually kicked in for analytic processing. So lots of use cases of in-memory, very similar themes for faster performance, reduced size, and fast analytics and transactions. I would like to ask, my final question is, assuming you're interested in memory, you're here because you have an interest in memory, and if you're not using it today, what can we do to help you with? What can we do to help you? Do you need to first upgrade from older release? I mean, 11.204 is still widely deployed. It's a good release, but obviously we can't help you with that. You have to first upgrade from an older release. And if that's the case, please let us know. Do you need help understanding the technology better? Do you need help identifying what the use case workloads are? There are cases where in-memory is not a good fit. If all you're doing is transactions and there's no analytics at all in the workload, which I guess can happen, it's not a good fit for in-memory. It's not going to make it better because you're not running reports. So if you need help finding out what the right workload is, that's something we can also help you with. Do you need help identifying what the right data is to store in the column store? Because memory, of course, is not abundant. It's not infinite. Do you need help figuring out what objects to put in the column store to begin with? And there is some work we've done to make that selection process more automatic that others will talk about, but is identifying in-memory candidates an area that you think you could benefit from? And of course, my favorite answer would be you need no help because you are already using in-memory. So wherever you fit in the spectrum, please feel free to fill out the poll and let us know. I would like to wrap up just with sort of one observation about complexity. Complexity is the enemy. So just because something is sophisticated doesn't mean it's efficient. You need simplicity for efficiency. Historically, everything that's actually become mainstream is because the thing was fundamentally simple. The reason relational databases became mainstream was that at the fundamental level, it's very simple. It's a very simple set concept. So SQL has become more sophisticated, but the core of SQL actually is very simple. So simple things become mainstream. This type of proliferation of enterprise sprawl is hard to make mainstream. Now, when you adopt complexity, a few things happen. I've seen this over and over again, but let me repeat my experience with people dealing with complexity. The first stage is denial, where somebody sees that and says, well, you think it's complex because you don't understand it. I've built a system. It's actually very simple. So that's called denial, where you look at that site out there and you don't think that's complex. You say it's simple. That's because you're in denial. The next step is you suffer from pain because it's broken. There's pain, there's anguish, and it takes time to fix because of the complexity of the interconnections. The next step is, after you've gone through a painful process of escalations and upset customers and whatever, then there's anxiety. You want to know, well, when will it break next? You have this uneasy calm before the next incident. And when this happens enough, there's pain and anxiety, depression sets in. You think, well, this architecture is hopeless. It's always going to break. So, and I've seen this happen to people. They look at the system, they say, my goodness, my system is so fragile. I can't, not a week goes by between some critical escalations. That'd be after 3 o'clock in the morning, answering pager calls. My CIO is calling me, asking me, why is the system down? Now, I have to confess, I haven't seen the final stage actually happen to anybody, but I can imagine if you get sufficiently depressed long enough, you might resort to other means to break the depression cycle. So substance abuse is a definite possibility for someone who's depressed perpetually. So we don't want that. We don't want that for anybody. So my recommendation is just say no to complexity. Avoid the urge to add gratuitous sophistication that ends up being just overly complex. Simplicity actually is the end result of resolving complexity. So this is the goal every enterprise architecture should have, is to be as simple, as homogeneous as possible. The reason the mega cloud vendors, like Amazon and Google and even Oracle OCI are successful is because they build the cloud out of a few specific parts. If you go to AWS, you go to OCI, you're not going to find 3 million choices for compute shapes. You get a small number of shapes. So you pick a small building block and then you can replicate that at scale. That's what simplicity is all about. It's fine to be of massive scale. You can build massive scale with simple components, but you want to make sure your components themselves are simple and robust. I'd like to just share some contact information with you. Ranjan's already done a good job sending this out earlier, but if you feel like taking a screenshot, please feel free to do so. So we have the product management team all present here today. We have Shashank who will be presenting also later on from InMemory Development. He's the VP of InMemory Development. Andy will do a presentation also of InMemory best practices. So feel free to reach out to them directly if you have any questions about anything. To try InMemory out, you can download Oracle's free Express edition. It's currently based on 18C. There is a plan to upgrade it to 19C, but right now the 18C version is available. You can deploy it very quickly on your own laptops with a 2 GB column store and try it out. If you have Oracle Database Enterprise Edition 19.8 onwards, there is a completely free in-memory base level option that's available with the product. In-memory is a paid option. It's a licensed feature, but the base level is free. It's part of the base product. You can get an up to 16 GB column store capacity per database instance. And believe it or not, in many use cases, you don't need a lot more than that to get work done. So it actually is a credible size to run certain applications as well, depending on where your hot data really is. Please visit the InMemory blog. There's a lot of information there. A lot of updates get posted there regularly. We have a very nice technical brief that describes the technology. Provide a link for that. And I would recommend everyone try out the Autonomous database for free. There is a free tier of Autonomous database. It's not for in-memory specifically, but it's for all of Oracle's converged database capabilities. In-memory is sort of behind the scenes and silently enabled in Autonomous database. But you can try out everything, all of Oracle's converged model, all of the machine learning algorithms, all of the the graph or spatial database algorithms. All of them are available for free on the cloud, and it's very easy to spin up. I mean, I've tried it myself. You can literally have a database up and running within 5 minutes if you visit this link and sign up for the free tier. So please do that and get some experience with Oracle's autonomous database and converged database strategy. And with that, I think I am all out of time. I'm going to leave the poll open a bit longer because I would like to see some more responses. I would encourage all of you to respond to the poll. You took the trouble to come here, and I appreciate that a lot. It's a very easy task just to click on a few choices. So I know that we've got several people who responded so far, but let's see if we can get it all the way to 100%. And then once the poll is, once everyone's responded, I will publish the poll. So I won't let you go without seeing your own results. So please, and I do encourage you to finish the poll. It'll help all of us define the content also for the next set of sessions. So with that, I will end my share and hand it over to you.
Yeah, thank you, Tirthankar. I like what you said, die by DIY, trying to do everything on your own and add complexity. So with that, we invite the next keynote speaker, who is Rich Nemec, and he will talk about how to leverage technology and use in-memory for acceleration. Rich Nemec is the current CIO of Viscosity NA. He is the Oracle ACE director and former CEO of Tusk for over 20 years. Rich is past president of the International Oracle User Group, and he is in the Chicago and ENY National Entrepreneur Hall of Fame. So like I mentioned, he will talk about leveraging technology, which is about creating the future, will depend upon the speed and security of the database and the Oracle's ability to leverage the big data and IoT using technology, including machine learning and AI, and make in-memory a crucial benefit for performance. His session will look at how to leverage Oracle and use in-memory for speed. Over to you, Rich.
Hey, thank you, Ranjan.
Rich, you probably need to be a little louder.
Sure. Thank you, Ranjan. And I want to start by saying we live in an amazing time with incredible technology that Oracle has worked on for decades and now can be leveraged in various ways. And this is going to be a session on how you can leverage that to really take advantage of what they've done with in-memory itself. Ranjan talked a little bit about me. There's a little bit more here. If you download the slides, you can get that. I work for a company called Viscosity. We don't just do Oracle. We also do AWS. We do Azure, etc. We also do different apps, and we do a lot with the data itself. But I'm going to focus on what's important now for you. As you look at all the advancements in technology, you can't build things, as Tirthankar talked about, trying to glue a bunch of things together and build these very complex systems. And I'm going to look at the DBA and how this role is expanding. Innovation and how you can leverage some of those technologies like machine learning, like chatbots, like robotics, like big data, like IoT, and why in-memory is critical to have at this point in time because of those products and how they work. But the first thing is, if we just look at Oracle itself, let's go back to 1995, first 64-bit database. It means if I had the memory, I could directly address 16 exabytes or 16 million terabytes of data, but I couldn't do it because the hardware wasn't there. So what did Oracle do? They bought Sun, and they started accelerating the hardware world. Hardware used to come out every 5 years, 7 years. All of a sudden with Oracle, it was coming out once a year, twice a year, new products all the time. Exadata kept getting better, better, and better. Now they're buying machine learning companies. if you go to the last Oracle conference they had in person, San Francisco, the conference center is on the left of Howard Street and the right, and Oracle literally blocks the busiest street in San Francisco because they can't fit everybody there. Their appreciation event is at a stadium, sports stadium. When you look at where you are in history right now, people are moving from using digital with that computer in their hand to wearing it, to implanting it in the hive mind, which we're using right now. And really, all of this is happening as we speak. And it's disrupting companies. And there's been disruptive innovation before. Postal mail also was email. Telegraph became a telephone, became a cell phone. Floppy drive became a USB. Encyclopedia became Wikipedia. Filing cabinet became a database. Email started becoming Snapchat, Instagram. Wikipedia, all of a sudden I ask Alexa and Siri instead of looking it up. In a DBA, some of the work they do is being offloaded to autonomous database. But innovation is more than just tech. What does an innovative company look like? They realize that the current technology is passing and there's an emerging technology. And if you look at these great companies, they're leveraging big data, chatbots, robots, AI, and machine learning. Apple, notice they're a tech innovator, so they're a specific kind of innovator. Amazon is a retail innovator. They have their own Black Friday. It's called Prime Day. They also have an Innovation Day. Google is a marketing innovator, although they also leverage data with autonomous vehicles. So they look at images of people and other cars and cats using a product called TensorFlow. You can do that. And when you see one on the road with your autonomous vehicle, it says, don't hit these things. You could also leverage TensorFlow within Oracle and machine learning. But Oracle's focus is, let's make you the hero. Let's give you all the tools and make you the best marketer or make you the best retailer or whatever your business is. Oracle is all in on the cloud, obviously, and all in on machine learning. Q4 last year, Oracle OCI Cloud, 140%. This year's Q4 is coming up. Oracle bought datascience.com because they saw that every organization is looking at machine learning and AI as a key way to proactively develop a competitive advantage for them. But a robot may not look like one. Maybe they don't complain very much, but they do AI and machine learning, but they don't necessarily walk around. Alexa and Siri are both robots. They just don't walk around. How about robots that manage a database? Yes, they're here, self-managing, self-securing, self-tuning, recovering, scaling. I'll put the patch on before you even know the vulnerability exists. In a time when DBAs are managing way too many databases, you want to let autonomous database manage some of them for you. Will your job change? Yes, if you're the DBA. Yes, if you're the IT director, you're going to move those DBAs to be data administrators, to help data scientists, to do things like machine learning, to look at innovative ways to leverage technology. It is time for workers to worry about AI, but usually maybe white collar workers are okay for now, but only if you start to move just a little, become a data administrator. So if you know Oracle in this diagram, I believe you know 90% of the diagram. Learning something like Hadoop is just learning another feature of Oracle, or learning how to go through Big Data SQL to a NoSQL database is just learning another feature. So it really fits it. But data is the new oil. If you've never used InMemory Column Store, came out in 12.102. It has this in-memory area when I start the database. I can look at things row by row, transactions in the buffer cache. I can look at analytics, as Tirthankar talked about, in the in-memory column store. I look at it from running queries, having written one of the best-selling tuning series out there. I look at how many records are we doing with a given query? How many records am I touching? And you can see here with this insert and update, I'm only touching a few. If I use a not equal, all of a sudden I'm looking at a lot of records. But turn that sideways and now look at just the column. Think about how small they can compress some N's and Y's together and how fast this is going to be when I run this query now. It's going to be unbelievably fast. All I have to do is set the in-memory size. Andy will go into this a little bit more later. Access is the column of the data needed. I can compress that different ways. Uses storage indexes to prune things. I don't need my own indexes. I could use that. And then as Tirthankar talked about, it has CMD processing, which, oh, by the way, a lot of online gaming uses because they need billions of transactions per second. So what goes in the in-memory? Just basically, and I'm just showing you the basics to show you how easy it is. I'm not trying to teach it to you, but you're going to see how easy it is. I could do it at different levels here, but all I have to do, I create a table, just add in-memory. That's it. Alter a table in memory. That's it. I do need to populate it or do a full table scan. You're going to see in later versions, I don't need to do that anymore. And then when I run the query, I want to do some sort of auto trace to see, is it using the in-memory? I also can compress different columns in different ways. I could also say no in-memory for the depth no column. And then there's hints to turn things off or on. But the SGA has key things like the buffer cache data. If you're a DBA, you know that. The shared pool for statements. Now there's this new area called the in-memory area that I have to allocate separately. And Andy talks about this a little more as well. And then I'm going to build in-memory compression units for those tables. We're going to see for maybe JSON data in virtual columns. I'm going to use in-memory expression unit. But if I look at Oracle as they are growing, they're starting to use machine learning now. I have adaptive query optimization where, oh, I'm doing a nested loops. It's looping through, and the statistics collector all of a sudden says, hey, you've looped through too much. This is not what the statistics are supposed to be. I better change this to a hash join. So it literally is using machine learning in your queries right now. I could also have faster in-memory joins by creating a join group where the columns will share compression dictionary. And this will be covered a little more deeply later. But what I really like about it is big data SQL. Because something like Hadoop to me is not very secure. Many NoSQL databases are not secure. And so I like Oracle as that big data portal using big data SQL to go to Hadoop or go to a NoSQL database. And now in 12.2, I can partition that data, making things thousands of times faster. At 18C, now I can put that in memory. And it has support for Hive and other Oracle Big Data drivers, HDFS, and so on. How hard is it to do? Create a table, just add in memory to that external table. That's it. And now Hadoop can go to that in-memory external table up to 100 times faster. Could be even faster if you partition it. Maybe it could be thousands of times. In-memory JSON queries and virtual columns load into the IMEU or expression unit area, as you saw. And you could see some of this. You're going to see an example for this specifically. But virtual columns from JSON are loaded into these in-memory virtual columns. Some databases that came out more recently are very, very unsecure. And in addition to that, they don't have things like in-memory in different ways. In 21C, you're going to see in-memory spatial and text, which is very important as you create a user experience. In-memory vector joins, as was talked about earlier. In-memory hybrid scans. So maybe part of the query I get from the column store and part of the query I'm getting from the buffer cache. And then automating it. As I said earlier, in later versions, 21C, I now have a way to automatically populate and evict things into memory. And then if you go to the docs, you could see even more on the hybrid scans if you wanted to learn more about it. It's online right now. Or see the docs about some of the how it populates and evicts it when I set the in-memory automatic level to high. And you could see different compression units as one of Tirthankar's images. But I think maybe the best feature that came out was, hey, guess what? It's free. Up to 16 gigs. How amazing is that? Now, it doesn't have every feature. Things like automatic in-memory aren't in there. Oh, but I wish I had it in 19C because everybody tells me I should be on 19C. Oh, they backported it to 19.8. Now the base level is there. You can access the Oracle docs, as I said here. I can click on database feature licensing, go to database in memory, and I can learn more about the base level where it says you could experiment with this without purchasing database in memory. And there are some of the restrictions that it gives it here, but it's online right now if you want to find out. And then ensure you're using some of the other features in database JavaScript now, JSON. Instead of dealing with the Mongo apocalypse, if you don't know about that one on a document database, you should look it up. Think about AutoML, how to do machine learning, not by writing the notebook yourself, but by Oracle checking all the algorithms to see which one's faster. I'm going to show you that in a minute. Multi-tenant data guard, native blockchain tables. Now I can do blockchain in append only type of things. Persistent memory, if I have Intel Optane, get the entire database in memory. And then some more security enhancements. But when I look at Oracle, they're not making things 1,000 times faster. They're making things 100 times faster. They're doing it 10 times in this area and then 10 times in this area, maybe 100 times here, maybe 10,000 if I partition things right. But when I add it all up, it's millions or billions of times faster. And then Exadata just makes it that much faster with things like storage indexes. But the real benefit of Oracle is the security. Many databases that have been around a very short time say, oh, yeah, we do that security just like Oracle does. And they'll pick one of these things out. And they'll say, yeah, we do that. And I say, but what about all the other ones? You're the last line of defense. Things used to be magical, then they went to manic and even toxic. Protect people from themselves, or you'll draw their mistrust later. It's from a Gartner report on security. What else is coming? More data, big data, high volume, different values of data, different varieties of data, different velocities are coming in at different speeds, veracity, different truths of data. Do I need 25 different databases to do this? No. Oracle has been working on it for decades, and I can do it in one database. I don't need everybody to learn that. I don't need my staff to learn 15 things. I can do relational, JSON, key value, graph spatial, files, Node.js, Python, JavaScript in the database. Oracle Converged Database. Notice all the things that have come out free with the Oracle database. A lot of these things, people end up spending more with these other databases, and they have to have a staff to learn them as well. Data is the most valuable resource right now if you use it correctly and leverage technology to use it. Use it in memory so that machine learning can be fast enough to where it's valuable for you. Also, more data, IoT, all these small devices with not good enough security on them. In-memory makes IoT faster. Here's some different things. I always like this one because it's the refrigerator that tells you what you need to buy. It's locking the refrigerator because the bathroom scale has let the refrigerator know that, hey, with your connected home, you need to buy some more of these products before we'll open. And then if I'm a C-level CEO, let's say, I used to get what happened in the 80s. Then it was why did it happen? Then all of a sudden people gave me predictive analytics. What's going to happen? Now they're giving me, if they leverage technology, prescriptive analytics. What's the best thing that could happen? Prescribe to me what I need to do right now so the best possibility will happen. And then Oracle has also added machine learning into all their applications. So if I'm using Oracle applications, I want to make that faster. InMemory is going to make it faster. And you can see all the different products they're using InMemory in. Things such as manufacturing, just a couple of examples where I look at quality, yield. You know, supply chain is becoming a bigger and bigger issue. Wouldn't it be nice to very quickly see that ahead of time? Wouldn't it be nice to see, as you know, it's very difficult to find employees to some degree, who are the most important employees I have now, and do they plan to leave based on the things I've come up with? And what are the things I've done? Have I given them a raise lately? And then then I could do a what if scenario to say, what if I gave them more money? Maybe that's not as important as giving them another week off. So machine learning is very powerful, but I have to understand, what business goal do I want to solve? Am I classifying good and bad customers? Am I looking to prescribe or predict numbers in the future? Am I looking for the attributes that make my customers good? Am I clustering big data that's out there? Am I looking for anomalies, for fraud, maybe? So first, what's the business problem? Then, what's the function? Oh, classifying customers. Oh, what algorithm do I want to use? And you're going to see with Oracle, I have multiple algorithms with each business problem to use. Then I'm going to train the model. I'm going to use 60% of my data and train the system. Then I'm going to use the other 40% and say, how good did you do? Just to see if I've used the right algorithm and it's doing well. But you don't need any more algorithms than you can get in Oracle right now. It is quite amazing for classification functions, classify things into good and bad customers, and notice all the different algorithms you have, 8 different algorithms to choose from. Clustering into different groups, maybe age groups. I'm going to cluster big data because this age group buys my product more often. Maybe look for fraud, or maybe time series. Maybe I sell things in certain seasons. I want to look at the numbers and predict what the weather's going to be in the future, or attribute importance. These are my best customers. What makes them my best customers? Association rules. What do they buy together? Oh, they buy bread and milk together. Oh, they buy milk and eggs together. I can do feature extraction, text mining. Maybe I'm going to mine text and reviews to see, you know, good or bad reviews that I'm getting there. Then Oracle has built-in predictive queries, SQL analytics, statistical functions that they built for 40 years that they've been building on. And then if I want to use R or Python, that's okay. That's integrated. As I said earlier, TensorFlow is integrated. And they also have Apex, which is free. A real short example would be anomaly detection. I'm going to take this from, you know, a time view from way back in time. Well, 50 years ago, they were working on mathematics to say, what if I drew a circle around these points and anything outside the circle was an outlier? This is how they do anomaly detection. Now it's an algorithm that leverages that math called support vector machines. And then you also have, I'm going to classify good or bad customers, not by the green line. That's not very good math. The blue line, that's pretty good math, but the red line is spectacular math. Took them a long time to develop it. Then it took them a long time to develop the algorithm. Now what we have is an incredible product that we have. And how easy is it to do? You know Oracle? Well, it's pretty easy. All you do is PL SQL. Just have to call the algorithm, go to the table based on the customer ID. Are they going to buy this new credit card I have out there? That's it. And then I'm going to test it, or I'm going to use it on some data to say, give me a list for my salespeople on the most likely people from this big data that are going to use my credit card. But Oracle made it even easier, if that's possible. In 21C, they have auto machine learning. Automatically looks through the algorithms to see which one's best. automatically looks through my data, gets the right sample size, denoises the data. If there's missing data, it'll fill that in. Auto tuning. And then it'll build that model for you. So I had a notebook. If you're a machine learning person, you build a notebook, which is just a series of select or PL SQL or different statements or Python statements. And it took a couple of days. I tried all kinds of different algorithms. I wanted to know which one was the best for this classification problem. And I tried AutoML the day it came out, of course. And I created an experiment. I said, I'm going to classify data, see if they're going to buy this affinity card based on the customer. And I could do it for faster results or better accuracy. Here I did it for better accuracy. And it started looking at all these different algorithms. You could see it looked at 5 different algorithms, and it even tuned the algorithms while it was doing that. Then I said, oh, create a notebook, and it created a Python notebook for me. Took me 2 days, took it 4 minutes. It was done. 4 minutes. How amazing is that? That's called leveraging technology. And there, now I have my notebook. But when you look at machine learning, you're going to be doing this for the next 10, 20, 30, 40 years. You know, you just have to know what the business problem is at your business. Supervised learning. You have data. Classify maybe some pictures of things so that you can do all autonomous driving. Classify some things so you can find fraud detection. Supervised learning to forecast the weather for regression. Market forecasting using a regression algorithm. Or machine learning for unsupervised learning. That means I don't have the data. I'm just getting some data. I want to do some targeted marketing, cluster some data out there with big data, put it into age groups for me, or segment it into certain customers so that then I can look for customers that are kind of like mine, known as the eigen customer. It's going to take a long time, but what Oracle does is it lets you leverage technology instead of build all the pieces. They've done it over 20 years. Oh, and you could also have fun with machine learning. This is somebody who took paintings, Marie Antoinette, Henry VIII, Queen Elizabeth, and what would they look like today if you saw them walking down the street? And this is a snack cake item where they drew the picture, and this is what they would have looked like if the person ever existed, which they didn't. But we're heading into this twilight zone where things are accelerating. We're finally getting to 64-bit, which Oracle had 25 years ago. The shift from 8 to 16-bit, if I look at Windows and called it 1 mile an hour, the shift to 32-bit was like going 65,000 miles an hour. And it felt like it because we got the internet. Now we're jumping to 64-bit. We're jumping to 300 trillion miles an hour. And it's robotics and machine learning. You don't want to build everything. You want to leverage things. As you use machine learning, you need things like InMemory to make it fast enough. Some of the tech trends in Gartner, things that are coming, big data. In 2013, it was all about tech. Cloud computing was still coming. And then at this point in the graph, only 5% of the people are using it. And then further out, predictive analytics, 30% were using. 2015, it was all about robotics coming, hybrid cloud computing coming. 2018, all about robotics were digital twin. There's you, the DBA, autonomous database, your digital twin, helping you to get the job done better. Connected home was coming at that time. Augmented reality was just starting to hit people. And then it was all the security issues became bigger, 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 bigger. So how important was something like autonomous database? 2020, now we're going to where machine learning is coming. A lot of people are not using it a lot currently, but it's coming. And then what comes after that? It's going to be robotics. Put that exadata into the robot's head and use machine learning to do things. Are you leveraging for your company the database, GPS, robotics? It's available now with Oracle. Are you leveraging things like robotic process automation for things like applications? 85% can be automated. This company, E-Alliance, does it now. Are you leveraging AI for virtual reality? Oracle has it today. For mixed reality, Oracle has it today. For augmented reality, Oracle has it today. You can use it. Other innovations, AI in the apps we talked about, IoT apps. How about augmented reality and chatbots? Things come to those who wait, but only the things left by those who hustle. What you see now is going away, and we're moving to this new era. Star Trek used to look so advanced. That's why me and Tirthankar loved it. We thought this is not going to happen for 1,000 years. We're already past it. Now we're past Edward Scissorhands, where this guy's arm is his job. It's a tattoo artist that uses his arm, where people are starting to transcend biology. You have to look at, why did God put you on earth at the best time in history? To leverage this stuff, to make a better world. What did I talk about though? Know the Oracle. They're always first at everything. The DBA and expanded roles. Oracle is first at everything, but only until they get it right. They also leverage things within memory by using it with things like big data, IoT, machine learning, apps, chatbots, robots. There's a few references. And then all the impacts that people make. I mean, Dr. DBA, what a great impact he made. Joel Coleman with the Apex product. Larry Ellison and Mark Benioff, Rebels with a Cause. And they do with machine learning and medicine. And this is Yoshiki, I might add. But Oracle's never caught from behind. Great sales and marketing, great database, BI leader, in the lead except cloud, but now they're growing at triple digits. I think it's going to be game over with machine learning. They really are phenomenal. And with that, I'm going to pass it back to Ranjan. There's a few books you can get. If you're Asian, they have some Asian versions as well, many of the different ones. Learn from some of the Oracle aces. I was going to say one last thing. Oracle since 1977 has been number one on this list, and they are still number one. Things go up and down. Cloudera kind of rose, but then flattened out. Snowflake's kind of starting to hit the map. But Oracle stays number one. And with that, I'm going to pass it back to Ranjan. And there's my email and my Twitter if you want to follow things. And I appreciate being here and all the, I look at the people that are on this call giving you presentations, these people from Oracle, they are amazing, magnificent, transformational people that have given you a product built over decades of time that is phenomenal. Make sure you leverage it.
One thing I'd like to mention, Rich, thank you for that. One thing I'd like to mention, every time you speak, even if I've seen your slides before, I learn something new from you each time. So your presentations are very, very pithy. I have lots of great content.
Same for me. I learn from you guys all the time.
Yeah, definitely. Yeah. Thanks, Rich. I like again what you said. InMemory is the secret weapon for performance. So thank you for the very insightful presentation. With that, let's invite Shashank Chavan to the stage. Shashank is the Vice President of the Data and In-Memory Technology Group at Oracle. He leads an amazing team of brilliant engineers in the database organization who develop customer-facing performance-critical features for in-memory columnar store. He's going to talk about Oracle Database In-Memory technology designed with tomorrow in mind. Our database in-memory team is constantly innovating and adding new features to the product to best meet the demands of real-time enterprises companies of today and tomorrow. In this session, he will cover a broad overview of new technology we have developed for database in-memory. With that, Shashank, go ahead, please.
Great. Hey, thank you for the introduction. So yes, my talk today is Oracle Database In-Memory, technology designed with tomorrow in mind. And really the way that this talk is structured is I would like to present to you kind of the foundational set of features, like the core design of Oracle Database In-Memory that we used throughout the years to build upon new analytic mixed workload performance features that have only enhanced in memory over the years. And so that's, and then I will get to the new features that we have. So you've seen this slide before. This is our dual format architecture. And there are basically 3 key design requirements when we designed this architecture. Number 1 is we wanted to make sure that we can improve analytic and mixed workload performance by orders of magnitude. And it should have negligible impact to OLTP workloads. And so the idea here is because we maintain both the row store and the column store, and we keep them transactionally consistent with each other, you can get mixed workload performance by the optimizer choosing to go down the row store path, or the optimizer may choose to go through the column store path if it deems it to be an analytic query. The row and column stores must be simultaneously active and transactionally consistent. This is a very important design requirement for us. We wanted to make sure that when the data is populated and brought into the column store, that it would always be usable. You can always run queries against it, despite the fact that the table may have been updated. So it needed to be fresh, it needed to be consistent. And the last thing is it needs to be seamless to use with native integration to existing and future Oracle RDBMS features. So Oracle always tries to build our new features integrated with existing technology. If InMemory was a one-off and a separate storage engine, a separate query processing engine, it would make things very difficult for the technology to be adopted. And Oracle has 30 to 40 years of technology under its belt, right? We have partitioning and sharding and rack. All of these technologies have to work. InMemory has to work with all of these technologies, and they do. Diving deeper, so Tirthankar showed some slides, about in-memory database and showed, what an in-memory compression unit looks like. An in-memory compression unit, also called IMCU, is essentially a block of rows that we store in memory in the column store, about 500,000 to 1 million rows. And within each one of these IMCUs, we maintain all of the columns. Now, you can choose to have some columns in the column store. You can choose to have all of them. You can choose to compress these columns in different ways. We pretty much give you as many options as possible to store your data as you see fit: partitions, table spaces, etc. Okay. Now, what this slide shows is something really fundamental. On the bottom, you actually see where the rows are actually laid out on disk in extents in blocks. And we have a very tight mapping between the rows on disk to their location in memory in the IMCUs in the column store. And I'll explain to you in the subsequent slide why this is important. Um, but please keep this in mind, and I'll bring this up again at a later point. Another important foundational feature that we built into the Oracle database in memory is how do we make analytics run faster on modern CPUs? So modern CPUs today have what Tirthankar already described as SIMD instructions, or single instruction, multiple data. And what these instructions allow you to do is really vectorize your algorithms or your queries that you have. So SQL query can be compiled into essentially an algorithm. And that algorithm can be optimized using these SIMD vector processing instructions. And the example that you see here is find sales in state of California. So the first thing that we can do is ignore all of the other columns in your table and just load the state column. So that's benefit number 1, if you will. We only need to load the column that's being referenced. The second thing is that when that state column is loaded, we load it into this CPU register, a SIMD CPU register that is a very large register. It can hold 64 states at any particular time. So you do a load and you have 64 states sitting in this register in one CPU cycle. The next step is to perform the comparison of all those 64 states to California. That comparison operation completes in, again, a single cycle. And at the end of that comparison, you have a bit vector that says pass, no pass, pass, no pass, etc. for 64 states. So as you can see, if we process data using vector processing, we can literally process rows at billions of rows per second compared to the millions of rows per second that you would get with the row format. Now, all of our, or many, I should say, of our analytic features that we built on top of the database in memory really leverage CMD vector processing. And we'll talk about that as we go along in this presentation. Another key, again, foundational feature that we have benefits mixed workloads. And that has to do with our architecture itself, this dual format architecture. It enables fast mixed workloads and even faster analytics. So what we can do is we have very fast in-memory DML because an invalid row is logically removed from the column store. All we need to do is just set a bit. So let's go through an example. Suppose that a row was modified, was updated. So it goes through the same traditional path that you're all familiar with. There's no extra overhead spent in terms of updating that row. And in your buffer cache, that modified row will be sitting. Now, what happens next? Once we've identified that this row has been modified, if you recall, we have a tight mapping between the location of that row on disk to its location in the column store. So we can quickly find that row and simply set a bit that says this row is now invalid in the column store. Now, that's it. So that's what happens with DML. It's a very fast operation, and it's a logical delete of that row in the column store. Now, when you want to run an analytic query against the column store, we simply ignore the invalid rows in the column store and just vector process all of the valid rows. The invalid rows are separately processed through the buffer cache. And in that way, we always get transactionally consistent results. Now, the columnar data in memory is smartly refreshed over time. As you can imagine, as the rows start to become dirty in the column store, we don't want to continue skipping over those invalid rows because we're basically just wasting CPU cycles. So we want to refresh or repopulate those IMCUs that are dirty over time. And that's where it comes to our fast background repopulation feature. This is, again, technology that we build on top of our foundational set of features, our dual format architecture. So we use continuous intelligence to track how dirty an IMCU is and how frequently it is scanned, and then when to take action to refresh or repopulate it. I'll go through one example of how we leverage this analytics here. So basically, we're doing analytics on ourselves, right, to take the appropriate action. So once we determine that this IMCU is dirty, it has too many invalid rows in it, we will, in the background, build a fresh new IMCU, basically remove the invalid rows and refresh them with their updated cells. Once that new IMCU has been built, we will then switch out the old IMCU and put in the new IMCU. Now, the reason why we keep that old IMCU around is because we want queries to continue to benefit with the in-memory columnar scans against it, and only switch it when the new IMCU is ready. Okay. Similar to double buffering, we have other techniques. Incremental repopulation allows you to to rebuild or refresh the IMCU by using the old IMCU and how data was encoded there to encode the columns in the new IMCU. And column level invalidations is a nifty trick that says, I will, if a row was marked invalid, but it only touched or updated 2 columns, as in this example, the third column was untouched, meaning it's still valid. What that means is simply we can still run a query against that column should the query only touch the column that was unaffected. That's called column level invalidation. So these techniques allow us to very quickly refresh dirty IMCUs, dirty data in the column store, and also allow mixed workloads to perform very efficiently. So similarly, we built additional analytic features on top of the vector processing framework, the columnar representation of the data, the compression and the encoding formats that we use. So for example, we have in-memory expressions, in-memory join groups, in-memory JSON, and in-memory optimized arithmetic. In-memory expressions is a way for us to automatically add an expression as if it was an added column to your table. So in this example, price times tax will be treated as a materialized column in your column store so that you don't have to compute price times tax. You can just look it up. In-memory join groups basically replaces your traditional hash join operation with a much more vector-friendly join operation that just involves a direct lookup into a contiguous array. It's basically a single random memory access. And that replaces the more costly hash joins, replaces the hashing costs, the probing costs, the comparison costs, all of that makes hash joins very expensive. In-memory JSON is a way that we store JSON in the column store in a binary representation called OSON. And it is not just a more compressed representation of JSON, it is also a very query-friendly representation. And not only do we store that in this OSON representation, we also have a cool technique where we shred the JSON into its key value pairs. And it's almost as if each one of those key value pairs is conceptually a separate column now in your table populated in the column store. So now should you run a query that says, hey, I want to find all locations where the movie that's being played is Rogue One. Now you're basically using the vector processing techniques that we talked about with the CMD instructions to process that query at the billions of rows per second speed. And the last thing is in-memory optimized arithmetic. The short story of this is Oracle numbers is a very expensive data type that we have. It's a software implemented data type. To perform an operation using Oracle numbers can be quite expensive. So if you have an application that is numeric intensive or aggregation intensive, number arithmetic is very expensive. We replace numbers and encode them in a binary representation in the column store. And now we go from 80 some cycles per arithmetic operation to 1 CPU cycle per arithmetic operation. Okay, so this is just an example set of features that we have built over the years since 12.102 when we released in-memory, then 18C, 19C. We keep adding features to improve our analytics story here. Okay, switching gears just a bit, I want to now talk about how in-memory integrates with existing Oracle technologies. As you may recall, that's a very key requirement when we first designed Oracle Database in-memory. And what better way to describe how we integrate with existing technologies than to bring up Exadata itself. So Exadata is Oracle's premier database machine. It's designed to run Oracle as efficiently as possible using the best of breed hardware technologies that are out there. The way that the servers are spread out in the Exadata box, so you have the compute nodes sitting on the top, and they're separated from the storage nodes that are sitting on the bottom of the rack. And the storage nodes have huge amounts of flash arrays, and we use that flash primarily as a cache. And so if you're familiar with smart scans or Exadata smart scans, that's where we use this flash cache to keep our data and reduce the amount of I/O that we go through. Now, when you run in memory on Exadata, your columnar data, your tables, partitions are all stored in DRAM in the compute nodes, and that's where the in-memory columnar scans happen. Now, when you have in-memory on Exadata, you can actually extend in-memory processing to the storage nodes. And so what you see now is you see data that's populated in the DRAM on the compute nodes, but you also see data that can be populated using the same in-memory columnar data formats, but now in flash cache. Okay, so the bottom line is we get significantly more columnar capacity, hundreds of terabytes now, because we can extend our in-memory processing to flash cache, and you get the same columnar data formats in DRAM as you had. You get the same columnar data formats in flash cache as you have in DRAM. You get the same in-memory optimizations as well. And this is completely automatic. You do not have to do anything. You can just run your query and it will automatically get populated in the flash cache. And it is a cache, so the hotter the data, the more likely it will stay in that cache. This technology, by the way, is literally what powers the autonomous database, the autonomous data warehouse and autonomous transactional processing. This powers it. Underneath it all, we are running in-memory technology on flash cache. Okay, another very key technology that we have is something called self-driving column store. So this question has come up a lot in terms of how do we manage what goes into the column store, which tables, which partitions should reside in the column store. So we have a very smart system built in that determines this for you. It will identify which data is considered hot, what's intermediate, and what's cold. And it will automatically evict out the cold tables and bring in hotter tables. And in this way, the column store becomes completely self-driving and automatically managed. Okay. I'll go into more details on this later in terms of some new features that we have with this technology. So that brings me to the what's new section. So going back to where we just left off on the self-driving column store, this is an area that we intend to improve upon with every release. Okay, our goal is to make database in memory as easy to use as possible, right? And so the first thing that we have is with a special level, a high level of this automatic in-memory management feature, all tables automatically qualify for in-memory population. Okay, so that means populating in the DRAM and the compute nodes if you're running on Exadata. We more aggressively compress cold columns. Okay, so you may not want to evict out that table, but you don't have enough space. And so we will automatically find those columns that haven't been accessed and just compress them big time so that they're still in memory, but it'll cost you a little bit more to access them should you need to. Okay, where are we moving to? So as I mentioned, we want to add more and more smarts into this feature. So for example, we want to be able to auto size this column store depending on your workload. We want to be able to predict which tables will be accessed next so we can pre-populate them into the column store. Okay, so that's the direction that we're heading with automatic in-memory management feature. The next slide here talks about what are we doing in the converged analytics space. So I talked to you briefly about JSON and how we store JSON in a much more query efficient data representation in memory. And the beauty about in memory is we can store our data any which way we want. We can encode it however we want so that we get the best compression without sacrificing any performance. In fact, gaining significant performance. So this is an example of what we do with spatial objects. Spatial objects are quite large, and query processing on a spatial object, for example, finding a point in a polygon is a very typical type of operation. In this example here, we are trying to find which parcel has a utility valve in it. So this is kind of like saying, hey, I really want to know which building has this particular bathroom, let's say. That's a reasonable example. So what we maintain in the column store is essentially a summary. We keep a summary of that object, which is an approximation of that spatial object. And it's encoded in such a way that when we want to run this filter, in this example, which parcel which parcel has this utility valve, it now transforms into a vector processing query. Again, using those CMD instructions that we talked about. And again, we're at the billions of rows per second now, scanning through these spatial objects. Okay. I know I'm running out of time here, so I'm going to just quickly summarize this last slide. I think it's the last slide. And talk about vectorized analytics. So Tirthankar mentioned, I mentioned that again, our foundational feature when we first developed Oracle database in memory was built on our columnar representation of data and encoding them in a way that makes vector processing through them using CMD instructions as efficient as possible. And we pretty much did this at the filter level, at the scan level, when we're processing a table. But we want to extend it beyond a table scan. We want to extend vectorized analytics up above into the SQL tree. So get into aggregation, get into joins, get above the traditional single table scan operator. And this is a framework that we built called InMemory Vectorization Framework that tries to achieve exactly that. And the first example of this framework is something called deep vectorization, where we basically make join processing faster by breaking down the operations into vectorized processing kernels. Okay, so I won't go into more. There's a lot more information on this in various different blog entries that we have. I'm going to, given the time, go ahead and skip the hybrid scans. The base level feature has been discussed by Tirthankar. This is a feature that we have that allows you to use in memory for free, up to 16 gigabytes in your column store. And Andy Rivenes will talk more about this feature as well. And lastly, we have a lot of other miscellaneous features and enhancements that we've been working on. Hardware acceleration. We don't stop whenever there's a new CPU. In fact, we get excited whenever there's a new CPU that's coming around, because that new CPU has new instructions, and those new instructions will allow us to make our analytic queries run faster. We can vectorize those queries more efficiently with these new instructions. Converged analytics, again, we won't stop here. We really believe firmly that Oracle should be a one-stop shop, meaning you should be able to run your graph workloads on Oracle, your spatial workloads, your text workloads, JSON, etc. They should all be working on Oracle. And so what we need to do is make sure that they run efficiently. Everything else will work out, and that's what we're working on. Continue to push more and more functionality to Exadata as part of our scan offload, and leverage that large flash columnar, that flash storage that we have. And focus on compression, bring external tables into InMemory. We already have that feature, but continue to advance it. And then leverage some of the newer memory technologies that are out there, specifically persistent memory. Okay, lastly, if you want more information, this is a blog that we maintain. Feel free to please take a picture of this and visit it. Again, Andy Rivenes, who's coming up next, will talk to you more about how you can get more help as you need it. And that's it. Thank you very much.
Thank you, Shashank. There are always so many innovations to cover, so thank you for covering it in a short time. So with that, let's invite Andy Rivenes to the stage. Sorry that we are running a little late, but this is one of the best presentations. So Please don't miss this presentation. So Andy Rivenes is a product manager at Oracle for database in memory. Prior to that, Andy was a product manager for several other Oracle features and capabilities. Andy has spent a large part of his career managing Oracle databases, and he now spends his time helping customers implementing database in memory. His topic is Oracle database in memory tips and tricks for getting started. Andy, over to you.
Thanks, Ranjan. Hello, everybody. My name is, again, Andy Rivenes, and I am a product manager for database and memory, and my email address is there. You can follow me on Twitter and in our blog, which Shashank also showed you the resources page, which I'll probably mention several times. We do have a lot of information about database and memory there. I'm just going to cover the highlights. We don't have a lot of time, but there are some definite best practices that you can follow so that you don't wind up reinventing the wheel, as I like to say. On our resources page, everything I'm going to talk about tonight is available in our quick start guide, which, as it says, is something to help you get started quickly and not having to guess about how to set up database and memory. Yes, it's very simple, but as with a lot of things with Oracle, the devil's in the details. And then we have our implementation guidelines there as well, which goes into much more depth about database and memory and what you need to consider in implementing it or running database and memory. And then don't forget our documentation, our database and memory guide that we have in the documentation set, which also covers lots of information about database and memory, syntax, how to set it up, and lots of other information. All I really want to make sure is that everybody understands that database and memory is really targeting analytic workload, what if type questions. I think we've made that clear, but folks always kind of hear in memory and they think it's going to speed up everything. We're really focused on columnar formatted data, being able to populate that in the column store, and then having it available with the row store. So you always have objects in the row store, and then we can populate those objects in the column store if you've enabled them for in-memory. And then it's really just a cost-based decision whether the optimizer decides for your SQL statements, do we access the column store or the row store, which means you don't have to change your applications to take advantage of database and memory, which is huge. Very simple to set up. Literally, you set the in-memory size parameter. For the DBA types, we're going to allocate the in-memory area or a column store in the SGA. We'll talk a little bit more about that. Alter tables, partitions, subpartitions, or materialized views to be in memory. Possibly drop analytic reporting indexes, not constraints, not OLTP type lookup indexes, but analytic reporting indexes. And that's really all there is to it. And it's very simple, but like everything else with Oracle and computers in general and technology, there are a few more details that it's good to be aware of. Database and memory is available anywhere Oracle database runs, Database Enterprise Edition, Oracle Database Enterprise Edition. We first introduced database and memory in 12.102, subsequently 12.2, 18C, 19C, and even, as Tirthankar mentioned, 21C is out in limited availability. It's available in the cloud, available on premises, available on Exadata, available and even in database XE. So anywhere, again, I like to say, anywhere Oracle database runs, database and memory will run. So how do you know if you're going to benefit from database and memory? So we have something called the In-Memory Advisor. You can download it off of oracle.com. It's free. You don't have to have in-memory enabled. You can even run it on 11.2 databases. We have, in addition to the In-Memory Advisor, some white papers or technical briefs that talk about how to use or set up the In-Memory Advisor and then how to interpret it. It uses AWR and ASH data, so you do have to have the tuning pack license in order to access AWR and ASH data. But what basically it does is it'll take a look at snapshots of your existing workload, preferably where you're seeing analytic workload or where you think you have reporting workload. And it'll take a look at that and determine, is there benefit or would there be benefit if in-memory was enabled? So we'll get kind of a high level, this is the benefit you can expect. This is how much memory we think you might need. And we'll then drill down and look at SQL statements that it thinks will benefit, objects that could be placed in the column store. It'll even list off the syntax, the alter table commands to help you enable database in memory if you choose to make use of it. Use the latest version of Oracle database. Kind of everybody always talks about that, but even though you can start with 12.102, I mentioned the other versions, 19C is the long-term release for Oracle database currently. And so we would recommend that you start on 19C. It has lots of features that we've added along the way in our journey with database and memory. And it's really a great place to start. In addition to that, always be on, no matter what version you're on, always be on the latest proactive bundle patch if you're on 12.102, or the latest release update if you're on 12.2 or higher. I've even included the MOS notes that you can use to start to investigate that. We get people who say, well, we're on PSUs. So PSUs are not the same thing as a proactive bundle patch or release update. Their proactive bundle patch or release update is a superset of a PSU and has the fixes for database and memory. So you're really putting yourself at a disadvantage if you don't, based on your release, get on at least a relatively current, within the last 6 months or a year, bundle patch or release update, and preferably the most current if it's possible, since you really are starting off taking a look at database and memory. In addition to that, if you're doing an upgrade, which a lot of customers do, take a look at your initialization parameters, especially the underscore parameters. Lots of folks carry those parameters along with them through different versions and don't really know what they're being used for. The problem is database and memory uses lots of new technology, and some of those parameters that maybe have been set and you're not sure what they're for can disable the ability of the optimizer to leverage all of the features of database and memory. So if you don't know what they're there for, we strongly recommend, and this is something that Mike Dietrich and Roy Swanger, the upgrade guys, recommend as a best practice as well. So it's not just us. Try commenting those parameters out and running as much as a default environment as you can to fully take advantage of all the features of database and memory. Hopefully I got that point across. Don't steal memory. So this is my picture of the SGA with the in-memory area allocated. Notice it's really large compared to all the other areas. And so that's typically what we would expect to see. But if you say, well, I don't have really enough memory in my database server, I'm going to take some memory out of the buffer cache and out of the shared pool, maybe one of the other pools, and I'm going to give it to the in-memory area. Well, if you do that, it's likely that the workload that you're currently running that depends on those sizes is going to suffer. So this is the in-memory part of database and memory, is that if you need to actually think in terms of allocating or adding additional memory to the SGA, probably to your database server, in order to accommodate the in-memory area. That's the in-memory part. It is possible to grow the in-memory area later, but in general, you're going to want to set the SGA target large enough and the in-memory area large enough so that it doesn't have to grow, so that you have enough room in there to populate the objects that, for instance, the in-memory advisor recommends based on your analytic workload. In addition to that, don't steal memory from the PGA either. So the PGA is going to, since you're now going to run analytic queries within memory, probably larger analytic queries than perhaps you have been able to in the past, you're going to need PGA for sorting, for other activity for SQL execution. And so don't go stealing all of the memory out of the PGA to give it to the in-memory area in the SGA. So you don't, basically the message here is plan for needing additional memory to support database and memory. And again, that's the in-memory part. And don't squeeze yourself into as small an area as you can. Leave some room for growth, because data will grow as you have, especially mixed workload environments, as you're adding or changing data. You're going to start, it's going to get larger even with compression. And so leave enough room so that you don't run out of space. And people will typically ask, well, what happens if I have an object that does run out of space that I haven't been able to fully populate it? Well, we'll access that data in the column store still, but then we'll have to go to the row store to get the rest of that data, because you're always going to get a read-consistent view of your data. We're never going to give you an inconsistent view, because that wouldn't be Oracle database. So plan appropriately, allocate a little bit of growth in the column store. Fully populate your data. I run across this with customers. We have a couple of views that are you can use to determine how much space you've used from the in-memory area or the column store globally, and then $VRIM segments, another $V view that you can use to tell you what objects are populated in the column store. And very important, notice the bytes not populated field. So you want bytes not populated to be 0. In other words, you want to fully populate your objects into the column store. Again, if they don't fully populate, we'll have to go to the row store to get the remaining data that didn't get populated. That'll be slower than having all of the data populated in the column store. And just because the populate status says completed, it might say out of memory, you've got to, you're not fully populated unless bytes not populated is 0. It's a little different on rack, and I talk about that in the quick start guide. The bottom line is you really want to be fully populated. What if you just don't have enough memory? You've done everything you can do to get more memory, but you're just limited. And a lot of our Oracle customers don't run, very large memory footprints. You've not had to do that in the past. Compression Advisor, it's been updated to understand the different in-memory compression levels, so you can run the Compression Advisor against your objects. In this case, I have the line order table, and you can see how much space is going to be required for each of your objects in the column store. So the in-memory advisor is going to give you a guesstimate. The compression advisor is going to give you a very accurate picture of how much space is going to be required. Don't forget compression. So by default, we compress objects in the column store with mem compress or query low, but we have other levels of compression. I usually tell folks you can expect at least a 2x compression rate with your objects, but it can be much higher using query high or capacity low and high. So there are multiple levels of compression, and you can even compress different columns at different levels if you want to get that into that kind of detail. And that can buy you a considerable amount of additional memory, and it's faster to compress the data. Usually DBAs get worried about compressing the data, but even if you wind up having to use higher levels of compression, it's still going to be way faster than having to access that data from the row store. Columns can be excluded. That's another way to save on memory. Just remember that if you do exclude columns, and typically the ones you would think to exclude would be ones that you're not doing analytics on. Lobs are usually a good candidate. Anything that you've stored there that you aren't executing or looking at from an analytics standpoint, you can exclude those columns. Up through 19C though, if you exclude a column and then your queries access those columns, we'll have to go to the row store to get the data. In 21C, Shashank briefly mentioned it, but he ran out of time. We have something called in-memory hybrid scans, which allow us to leverage both the column store and the row store for queries that you've excluded columns with. And then rack. How does database in memory work with rack? So rack is a scale out solution for database in memory. In other words, if you're limited to the amount of memory you can put in a single server, but now with rack, if you have multiple nodes in a rack cluster, you can distribute basically data across all of the rack nodes and have that much more data. So if you have 500 gigs in one server, in this picture, you'd have 500 gigs on 4 servers of column store space. And then what we do is we distribute that data across the column stores. However, that implies that we have to use parallel execution or parallel query to access that data across all 4 column stores, because a single query executing on one node can't access the data in the other nodes. We don't ship IMCUs or in-memory compression units across the interconnect. Instead, we use parallel query to access that data on each of the individual nodes, and we only return the resulting rows back to the query coordinator. Something to keep in mind about the architecture of how database in memory works on rack, and we're leveraging not only rack, but parallel query. So again, database in memory, the theme here is that we leverage the other parts or technologies of Oracle database to make it work as fast as possible. Multiple levels of distribution. You can control that in the alter table command. By default, we're going to distribute by row ID range. If you have partitions or subpartitions, we'll distribute by partition or subpartition. However, since we're using parallel query to access that data, your goal should be even distribution. So if you're not using hash partitioning, if you're using range partitioning, you need to look at the distribution of your partitions. You may have to consider using distribute by row ID range in order to get that even distribution across all of the column stores. Something else I want to mention is DOP, or degree of parallelism. So we need to have a parallel query processor on each node to access the data in that column store, at least one. So you have to have a DOP at least as great as the number of nodes in your query or in the objects that are distributed across the column stores. Originally in 12.102, we required auto DOP. We don't require auto DOP in 12.2 and above, but we do require that the DOP be as great as, at least as great as the number of nodes. So keep that in mind. Our best practice is to use auto DOP even in 12.2, 18C, 19C. If you choose not to, for obvious reasons, auto DOP does have some drawbacks. And if you're not willing to manage it with Resource Manager and some of the parallelization parameters, then you've got to make sure that that your queries are running with the proper DOP. So heads up. How does database memory work with other database features? With Exadata, we've heard a little bit about Exadata. We have Flash. We have something called in-memory duplication. Basically fault tolerance. So we can mirror IMCs across nodes so that if one node were to fail, the data would still be in memory. Remember, it's always in the row store. So you're always going to be able to run your queries, but it's not going to be as fast as if it's fully populated in the column store. In-memory duplication can help with that. And then in-memory on active data guards. So these are unique features to Exadata. And what that means is you can then populate data in the column store on a standby database and run your reporting against the standby database with database and memory. So those are Exadata features available on all flavors of Exadata. So whether it's on premises, Exadata Cloud Service, or Cloud at Customer, Exadata Cloud at Customer, these features, and I guess I should change the three. We actually have just made available AIM on all flavors of Oracle database. And so I removed the AIM bullet, but I forgot to change the unique features. Sorry about that. And database and memory works with multi-tenant. So what you'd wind up doing is you enable or allocate the column store in the CDB, and then each of the PDBs in your multi-tenant environment can make use of the data that's in the CDB. Each PDB can allocate in-memory underscore size and allocate a certain portion of the column store. Obviously, the different PDBs can't access the same data in the CDB column store. It's basically, you get a slice of the column store. So you can only use as much data as has been allocated in the CDB. And what that means is, in this case, if you have 3 PDBs, you can use, one PDB could use all of it, or you could share each PDB could get a slice of the column store in the CDB. Bottom line is, it works seamlessly with multi-tenant, and you have the same basic options with the parameters in memory underscore size as you do when we're running single instance. Remember, 21C, you're multi-tenant now. You don't get single instance databases any longer, or non-CDB databases any longer. So that becomes an important consideration. So how do you tell if in-memory column store is being used? We had some of these questions in the Q&A today or tonight. And so database and memory, we're not going to speed up inserts, updates, and deletes. We're not going to speed up network round trips, PL SQL, row by row, or slow by slow processing. We're going to speed up processing in the database, typically in large sets of rows. That's the analytics part. And what I like to tell folks is, for a non-trivial amount of rows and execution time, if you're only looking at a few rows, if you're down in the hundredths or tenths of a second, it may be that a row access through an index is the fastest way. That's a cost-based decision. But for non-trivial amount of rows and execution time, database and memory is going to help if the majority of your time spent accessing data, joining data, or group by aggregations. That's where database and memory is going to really speed up your processing. And you can figure this out. You can see this in something we call SQL Monitor Actor reports, time-based evaluation of your execution plans. I have a technical brief on our blog in the resources page that goes through how to set up and look at SQL Monitor Active Reports. They are available in Cloud Control, the Enterprise Manager version of managing Oracle database. But what's interesting about this is notice that in the activities section, we'll tell you how much time was spent in each portion of the execution plan. In this case, we spent all of our time in table access in memory full. But notice if I highlight over that activity bar, it says CPU in memory. So you can actually correlate time spent in the column store scanning data, aggregating or filtering data, CPU in memory, versus maybe doing IO, maybe doing other processing, CPU processing, say sorting. And so you can see the benefit of running with database and memory right in the SQL Monitor Active Report. And this is really the only practical way to get that information. It is part of ASH. And so SQL Monitor mines that and provides that information to you. Very useful in evaluating the benefits of database and memory. Of course, you also have session level statistics. And I had a question about AWR. This is also in the AWR report, not only about scans, but also work done in population and repopulation, something that Shashank was talking about. So one of the takeaways here is that all of the things that you've used, the tools you've used to manage Oracle database still apply with database and memory, because database and memory is, again, fully integrated into all of the Oracle database features that are there. What's new? I'm only going to, the reason I bring this up is because once you've got database and memory running, you're getting benefits. You can look for additional features, additional speed ups. We've been working on this in 12.2, 18C, 19C, and 21C's got a huge number of improvements to database and memory. Probably the biggest one, in my opinion, is automatic in memory, the ability to self-manage the column store. We've done some blog posts and some Ask Tom sessions. If you want to dive into more details, I would strongly encourage you to take a look at that information. And then the base level feature, and I think this has been mentioned, but I wouldn't be complete if we didn't mention 21C, and then we backported it to 19.8. Even Rich talked about this. It really is a great way for you to be able to evaluate the value of database and memory by being able to allocate up to 16 gigabytes of column store without having to license the database and memory option. You set the in-memory force parameter to base level, and away you go. And then on rack, you can have 16 gigabytes on each of your rack nodes, so you can even scale out the base level feature. Again, we're leveraging all the technology of Oracle database. And again, this is a great way to see the value of database and memory. And with that, I'm going to conclude, and that was the whirlwind tour of best practices. I really do thank you for sticking with it, sticking with us, and coming to the summit. Again, our blog, our resources page, we have not only articles in the blog. Getting to the resource page is a little more difficult because of the menuing structure of the Oracle blog. So there's the URL, and that'll get you into our technical briefs. As I mentioned, the quick start and implementation guide, our live labs environment where you can try out database and memory for yourself, our Ask Tom office hours sessions where we've done tons of sessions on the different aspects and technical features of database and memory, and even our YouTube channel. So with that, I will turn it back to you, Ranjan. And that again was thank you very much. And that was again, the whirlwind tour of best practices.
Thank you very much, Andy. Yeah, a lot of best practices to cover. Yeah, thank you for covering in a short time. And thank you everyone to sticking here. So yeah. Again, a reminder that we have sessions tomorrow. There are two sessions covering real life applications and use cases. Please do call in. You will hear directly from database in memory customers. So please do call in. Tirthankar, any last minute something you want to talk about?
No, I just wanted to say thank you very much for attending. Let's keep this community going. The main reason for this summit was just to kick off having ongoing engagement. So please do participate in LinkedIn group that Ranjan has set up, and please feel free to email all of us if you have any questions about anything. We want to make sure this is an ongoing engagement and doesn't just end with this one summit we're doing. So, but
Yeah,
thank you
definitely.
for caring very much. Thank you.
Yeah, thank you all. Like it says, summit is just the beginning of collaboration. See you tomorrow again in the real life application of database in memory session. Thank you all.
Okay. Thank you.